This is a real photo of a brain neuron stained using the Golgi method. In 1899, Spanish doctor Santiago Ramón y Cajal used this technique to describe neurons for the first time in history. How we passed from that to ChatGPT can be understood with three stories that fascinate me. One of them is that we should have had that technology in the 90s, but a conflict of interest paralyzed the field for years. Walter Pitts, a kid from Detroit, is being chased by two bullies while he finds refuge in the local library. To avoid the conflict, he stays there for a long time. And then he finds a book called Principia Mathematica, a 3-volume work on the foundations of mathematics. He stays in the library for 3 days so he can finish the book. Walter sent a letter to Bertrand Russell, one of the authors, pointing out what he considers serious problems with the first half of the first volume. Russell was appreciative and invited him to study at Cambridge University when he was only 12 years old. The offer was not taken up. However, Pitts did decide to become a logician. 8 years later, Walter is 20 years old and homeless. He's working on a low-level job at the University of Chicago, and to satisfy his need for knowledge, he'd been sneaking into some lectures. It was then that he was introduced to Warren McCulloch, an accredited neurophysiologist. By this time, we are in the middle of World War II. The first modern computers are being developed for military research. Thousands of brilliant minds are working on this, like Alan Turing in England and John von Neumann in the US. Walter and Warren started an investigation to create a model of the brain, and this quest led them to create a mathematical neuron. Let's talk about that. Let's go back to our biological neuron. Here we have a representation of it. On this side we have the dendrites, which are basically the receptors of the neuron. And this structure is called the axon, which is going to propagate signals to other neurons when it's necessary. So what McCulloch and Pitts did was basically to create this structure where you have some inputs and an output, simulating what's happening in the real neuron. A key difference is that instead of neurotransmitters, the inputs are going to be zeros or ones. Another characteristic of the real neurons is that the connection between two of them will be stronger if they often communicate with each other. To simulate that, they used something we called weights. Let's do a quick example. Let's say we receive 0 and 1 as inputs, and then to calculate the output, we multiply these two and then sum the whole thing. 0 times 1 is 0, 1 times 1 is 1, and the sum of both is 1. The final characteristic of the McCulloch-Pitts neuron is that it has a filter that will allow the signal to be sent only if a threshold is reached. To explain this, let's say we want to create a neuron that will only trigger a signal when both inputs are 1. This is also known as an AND gate. To do that, we can simply set the weights as 1 and the threshold as 2. If both the inputs are 1, the output will be 2, and we will be able to send the signal to the next neuron. In other cases, we won't match the threshold and the signal won't be activated. When we say we are training a neural network, what we are doing is basically changing these weights to get a certain output. This simple concept is the foundation of all the modern AI we have, from ChatGPT to the Instagram algorithm. McCulloch and Pitts co-authored a groundbreaking paper in 1943. That paper was the only source that the mathematical prodigy John von Neumann used as inspiration for his von Neumann architecture, which is the base mechanism that the vast majority of modern computers use. This story is much longer. Walter Pitts ended up for some reason studying frogs, but we need to move on because there are 2 more amazing stories to cover. Frank Rosenblatt, a psychologist from New York, is doing a curious experiment. He is training rats to navigate mazes. Once they find the exit, he attempts an extraordinary feat, extracting brain tissue to infuse this learned behavior into other rats through a brain transfer process. This man was obsessed with transferring learning, and this quest made him famous, not because of the rats, but because of a machine. Rosenblatt was born in New York in 1928. He studied psychology, but his research interests were broad, from neurobiology to computer sciences. He was working at Cornell Aeronautical Laboratory in 1957 when he created the Perceptron, a device to simulate a McCulloch-Pitts neuron. The Perceptron was part of a secret effort to create a machine that could interpret images. The Mark I Perceptron had 3 layers: a camera that made a 400-pixel image, a hidden layer of perceptrons named association units, and an output layer of perceptrons named response units. Rosenblatt created a mini-brain and trained it with a lot of images with the goal of recognizing males and females. Although the perceptron initially seemed promising, it was quickly proved that the system couldn't understand the difference between males and females. Here's when the AI winter started. In 1969, a famous book entitled Perceptrons by Marvin Minsky and Seymour Papert showed that it was impossible for these classes of networks to learn certain things. This book, often misquoted, caused a significant decline in interest and funding of neural network research. But the paper only proved that the perceptrons with one layer couldn't model nonlinear problems, like understanding an image. All they needed was more layers and a new process to train the network. But the damage was done, and the public lost interest in AI. Frank Rosenblatt died in July 1971 on his 43rd birthday in a boating accident in Shakespeare Bay. It took decades until neural network research experienced a resurgence, and this revival was mainly because of a new algorithm that the next protagonist of the story popularized. While Rosenblatt is called the father of deep learning, Geoffrey Hinton is called the godfather of AI. Hinton was born in London in 1947 to a family of famous scientists. I spent over an hour creating this family tree to show you the brilliance of the family of Dr. Hinton. Hinton is a great-great-grandson of the mathematician George Boole, creator of the Boolean algebra, credited with laying the foundations of the information age. But we can also notice that 2 of his relatives participated in the Manhattan Project to create the atomic bomb. Hinton was obsessed with the idea of giving the computers the ability to think, instead of giving them strong rules with code. He wanted to continue the work on neural networks. The academic mainstream initially rejected Hinton's ideas, and although Rosenblatt's work demonstrated initial success, the AI winter later relegated this field to small investigations. Remember that we talked about training the neural networks. Complex neural networks are extremely hard to train. You can have millions of weight combinations even with small networks. Hinton focused on solving this problem, and in 1985 he published a groundbreaking paper with psychologist David Rumelhart, where they used the backpropagation algorithm to train multi-layered neural networks. This was everything we needed to start the revolution. It was the first time in history that a computer could represent the world to solve complex problems without specific algorithms. In 1987, Hinton accepted a position at the University of Toronto in computer sciences. While he was a professor, several notable PhD students started gravitating around him. One of them could be easily recognizable to you, Ilya Sutskever, the former chief scientist at OpenAI. Together, they won the ImageNet Challenge in 2012. AI scientist Fei-Fei Li created this event to challenge researchers to find a neural network that could correctly understand images like a human. She created a database with 14 million images annotated by persons. With a convolutional neural network called AlexNet, Hinton and Sutskever achieved an 84.7% success rate. According to The Economist, suddenly people started to pay attention, not just within the AI community but across the technology industry as a whole. The McCulloch-Pitts neuron is still at the core of our most modern AI networks. Rosenblatt's approach was right. Deep learning is now the mainstream technique for AI. Marvin Minsky, author of the book Perceptrons, remained skeptical his whole life. He made a lot of poor predictions even after being an expert in the field. In May 2023, Hinton publicly announced his resignation from Google. He explained his decision by saying that he wanted to freely speak out about the risks of AI. and added that a part of him now regrets his life's work. In 2024, he won the Nobel Prize for his investigation on machine learning. Ilya Sutskever left OpenAI in 2024 to create his own company, SSI, to focus on safely developing a superintelligence, an agent capable of surpassing human intelligence.